Hello, welcome to Chapter 2 of Hacking Web Servers. This is actually Chapter 2 of our Ethical Hacking and Countermeasures class, where we're talking about web applications. This time around, though, we're going to learn about a bunch of popular web servers out there and their various vulnerabilities, all the kinds of trouble you can get into with the old IIS, the different types of attacks you can find against web tools, things that you can use to attack web servers, and the importance of patch management. So hopefully when all's done, we'll know what's important about web scanners, list and use a bunch of countermeasures to prevent this sort of thing, and then we'll know how to increase the security of these crazy web servers. So basically, we're going to look at a bunch of various security issues that go on with these web server things. Unfortunately, server administrators have a hard job. It's not cool. We have to worry about bugs running around on our servers, malicious code, so people actually going out of their way to break things for us. The security of the networks upon which our servers sit. And then the whole thing's got to run smooth. You can't have errors and timeouts and things not working. It's got to run good. So chief among the issues you might run into are misconfigurations. You know, running a web server ain't easy, so sometimes people screw it up. Building operating systems isn't easy. Sometimes people screw that up. Building web applications, also not easy. Sometimes people screw that up. Sometimes, if you're using the default settings on your server, those are widely known and publicly available. So if you turn on a server that's default username is admin and the default password is please change this password, and you leave that like that, you've got problems. If some noble security researcher or friendly systems administrator finds a bug, fixes the bug, and creates a patch, but then your administrator does not decide to put that on the server, that's a problem. And then if you have some sort of policy issue or procedure that doesn't require you to regularly maintain your server, that's bad. So everybody who talks to a web server has a different, each constituency, as it were, has a different need. The webmaster, for example, usually assumes that the local area network's a safe space. It's a safe place where we can talk openly. The corporate internet, intranet, is supposed to be less threatening, a less hostile environment than the open wild west that is the internet. But these are the kind of threats we worry about: viruses, Trojans, malicious software, and then there's attackers who might cause us to lose sensitive information or give a toehold into the rest of the network or whatever. So the way that web servers run and the scripts that they're allowed to run while replying to remote requests, it's inherently vulnerable. A web server's goal in life is to be useful. It just wants to serve. And unfortunately, that means that they're inherently exposed to the wide internet, which might include, possibly could include some people who don't just have good intentions, conceivably. So a network administrator, the person responsible for the network, has to be concerned that a web server that's got issues potentially can compromise that network. Nobody wants a compromised network. That makes everybody sad. So ideally, the web server should be carefully configured so that only legitimate users can log in, and they're given distinct levels of privilege, distinct levels of access, and hopefully they're guided by the principle of least privilege. So the principle of least privilege says that give a user the bare minimum security that they need to get their job done or to be a customer or what have you. The end user doesn't want their computer getting owned. Their web browser is a potential hazard. Their computer is a potential hive of vulnerabilities. And then browsers are subject to active content like ActiveX or Java, JavaScript, Java applets. Basically, a browser causes your computer to run software, to run code, which can get you in trouble. Part of the threat arises from the fact that we came up with TCP/IP in a kinder, gentler internet era, where security wasn't such a big deal to us. Really, with the original advent of the internet, people were amazed that this stuff worked at all. They were like, "Holy cow, we got two computers to talk to each other." The thought never crossed anybody's mind that computer B over there could actually be up to no good. So what's a risk? Bugs on the server, misconfigurations are a problem. They let people do bad things, and bad things might be stealing classified information, or running commands on the server, or retrieving stuff on the server that they don't want to, or using the server for something it was not designed to do, like launching denial of service attacks on the rest of the internet. That's no good. Potentially, you can use the server to affect the browser and therefore the end user. And potentially, it is a risk that an eavesdropper can listen to traffic transmitted on the network, and if that traffic's not encrypted, you have problems. Sometimes people are up to no good beyond just defacing a website, and there's a bunch of ways you can do that. Potentially, you could become a man in the middle on that website and the user and put up whatever type of website you wanted. If the administrator password gets compromised, you're in trouble. If the DNS is attacked, either through cache poisoning, where we trick servers into giving out the wrong address, or social engineering, where we trick a human into setting up the wrong address. And you'll recall that a DNS just takes a web address and translates that into a number so that your computer can use the IP address. If you are unadvisedly using the file transfer protocol to send things to your web server, that can get you in trouble. Potentially your mail server can get broken into. Hopefully these things aren't on the same server as your mail server, or your web server rather. There are frequently bugs in web applications and frequently misconfigurations in how web apps are shared. If somebody doesn't know how to do permissions right, if they have their firewall attacked or their router, and have the router is the device that connects people to the web server. If that device is compromised and instead directs things to the evil web server, that can show whatever it wants to the poor victim over here, who will be sad when they see the wrong website. SQL injection is a problem on all websites that talk to databases and fail to sanitize their input. SMS can be intruded upon, as can Telnet. Neither of those are highly secure passwords at this point. URLs can be poisoned. Web server can have extensions installed, which can allow people in, and remote access services like rlogin or SSH or Telnet even, or some other remote service that the system talks to, can all be an issue. You will remember that a vulnerability is any weakness that can be exploited. It constitutes some sort of risk. There are all of these old school IIS vulnerabilities that the book walks you through that attack IIS, Microsoft's favorite web server. Not the world's best web server. It works. But all of these things have become an issue for it. The IIS data vulnerability, the : data vulnerability was built in. If multiple data streams NFS had for files, IIS screwed up, and then an attacker could display the code in that file for any data that was held in that file. So you don't really want your web server showing files other than the file that is on your system. If you don't get rid of sample code that comes with your server, people are going to know about it. So show code ASP, that's active server page, view code ASP, code ASP would let you view the code on server-side scripts. And basically, you tell it the name of the file you want to look at, and then you can look at that. Unfortunately, when exploited, you could look at the file and view the code of it, of any file, that was on the same hard drive as the script, and that is not good. Things like the registry you might not want people poking through. On backend data queries like MDAC, the framework for deploying applications that can access many different types of databases. Of course, IIS, trying to be useful, throws in the remote data access service component, and then some lucky hacker finds out that there are vulnerabilities that let users send random SQL commands to screw with the database, or to retrieve information, or to inject SQL of the attacker's choice. Not good. Buffer overflow we talk about often, where there's a buffer, and this program is only supposed to write to this, but some crafty programmer gets it to write memory beyond what it's supposed to write to, and then eventually that extra memory gets executed. Bad programming allows that to happen. So since IIS is a system user, if the buffer overflows, the command that gets run, that the malicious hacker created, is run in the context of the system user. There were issues with the internet printing protocol. There were issues with the IS API extension, both of which were buffer overflows. You send them more data than they expect because programmers didn't bother to check how much data was going in. And when you get beyond the intended buffer, up here, this code gets executed, but it can be whatever code you want, which is no good. Privileged commands are commands that have more permission than the user who wants to do that. So if proper permissions for memory allocation are not properly set, the user sbin swcons utility lets somebody execute code in memory that's not set aside for you, and then runs with system permissions. Can create files. You can create a file with insecure permissions, and then maybe somebody runs that. WebDev and remote procedure call exploits. WebDev is the web-based distributed authoring and versioning tool. Part of Microsoft's web server. It lets you publish stuff directly on a server, lets you change properties, lets you lock and unlock things so that if everybody needs to read something, but only one person's supposed to be writing to it at a time. And then it also gives you the ability to search content. So it's kind of a feature-rich, useful thing. But when you insert features, you potentially create bugs. So IIS has some components that do the following things. Something can listen to requests. It's got to manage the processes that are running, look at the configuration files. There's http.sys that listens for things. Windows runs with services, the www service, and the corresponding Windows process. Are the services that basically are the executed program running. There's a WAS, Windows Activation Service, that goes, and then all kinds of other potential vulnerabilities. And you'll probably see, if you ever look at the processes running on a Windows box running IIS-7, you'll see all this stuff in there. Potentially you could have FTP running. Front page was Microsoft's ill-fated web publishing tool. There's the IIS Manager, the Internet Printing Service we talked about previously that got them into trouble. The network, NTP is the network time protocol, and NTP is news time transfer protocol. The simple mail transfer protocol service also could be running, and the www service is your web server, basically. You can run active server pages, internet data connector, which is for passing data around in Microsoft apps, remote admin via HTML, so not using remote desktop with the remote desktop web connection. And then there's stuff to do server-side includes. A server-side include is when a web page pulls data from something else on the server, so it includes something server-side. And then that web dev thing we were talking about, there's a publishing service that can be turned on. Unicode directory traversal. If you take the directory traversal part, if you go from //www back to the C:, in Windows you just type cd ... Sometimes in a web directory you could get away with putting that ... into a URL, so http website.com /... and go back a level. That lets you, by putting something in the browser address window, to go back to the C drive and then go to the WinNT drive and then run calc.exe and cause the calculator to prop up. Once you can do that, though, you can get into all sorts of mischief because you can run command.exe, and then anything that the program, that the computer can do from command.exe, which is basically everything, you could potentially do. Canonicalization errors are a bad thing, and in the older versions of IIS, they existed there. So if you would send a malformed, quote unquote, I've actually got scare quotes now, would let you get to files and folders that were on a local drive with the web folders. So if there was a c://www drive that was your directory, rather, that was your web server directory, so your index HTML file would be in there. This is Microsoft, your index HTML file. You could get to any other file on that directory. Not good, as long as they were on the same logical drive, the same C drive, for example. Netcat's your friend. Netcat can be used to hack into any web server. Makes a nice backdoor in any web server, but can also be used to get into IIS. There's also an IIS exploit tool that automates all that stuff, will create Unicode strings so you can exploit that previously mentioned Unicode vulnerability. There is a vulnerability, and was a vulnerability, hopefully, in MSW3, Microsoft www print, responsible for IPP. So you could send it an oversized print request. Like, you didn't expect a print request that big, and that would cause a buffer overflow. Again, memory goes into space in the computer beyond the space it's supposed to be in, and the computer says, oh, look, there's a program there I need to run the next time it reads that up. So those happen because of unchecked buffers in some place of code that handles input. So you send in enough data, doesn't get checked, thing crashes. RPC decomp vulnerability was a big problem. The RPC ports 135 rather on UDP and TCP, 139 and 445, the NetBIOS ports, and 593, the RPC over remote procedure call over HTTP port, or any place where the services were enabled, allowed people to pwn IIS servers, which is no good. ASPs are poorly written sometimes, not all the time. Programs that act as web pages, so active server pages. Think like JavaScript, but maybe closer to PHP, something executed server side. Potentially could give somebody control over a remote PC, and then you could do nasty things like make Trojans that have backdoors on your computer. So logs are important. If you want to figure out why your server blew up or how you got owned, you're going to need those. A good idea to treat not just IIS log files, but all log files as legal evidence, because they're liable to wind up that way someday. A big part of being a web server administrator is making sure they're good. So write down all the things, configure them to read every available field, make sure your timestamps are good, and make sure you're using network time protocol to keep your timestamps in sync. There is nothing more frustrating than trying to figure out what happened and having to correlate logs from multiple sources when their clocks are just slightly off. So this clock is 30 seconds ahead of this clock, is ahead of 30 seconds of this clock, and we're trying to figure out what's going on with these three servers. It can literally drive you mad. Make sure they're continuous. So if there's a blank spot in your logs, you have a problem. And then make sure they never get modified. Ideally, send them somewhere other than the web server. Here is a list of lovely IIS tools, all of which discussed in the text that I won't bore you with. Cache write is a tool to help speed up security and performance on IIS servers. So it tries to appropriately cache files for you. IIS logs will let you take a look at, Link Delay will let you take a look at IIS logs. So go through and look at what's happening on your web server. There are lots of IIS log tools. Interesting to see the Metasploit framework listed as a good log tool. It certainly will do things to your logs. You can mitigate a lot of this if you just take seriously the job of patch management. If you are a web server administrator or any kind of server administrator, good idea to keep up to date on your patches. So patch, just a little thing, a little piece of code that fixes a problem in your application. A security patch is the remedy to some kind of known vulnerability that lives in your application. And sometimes, if there's something important, somebody will throw out what's called a hotfix, which is a package that fixes a particular flaw in a platform. And usually the hot in hotfix is that like needed to be done in a hurry. The patch cycle is the schedule of how frequently patches get deployed. So Microsoft settled in on this Patch Tuesday thing where the second Tuesday of every month they release the patches for all of their operating systems. And if you follow that cycle, you stay up to date with all their stuff. The idea being generally in a home environment, recommendation is just install the patches when they show up as soon as it is convenient, but do so with a vengeance. I mean, as soon as it is convenient, should be like save your work, take a coffee break, and let the patches install. If you're a corporate environment or a production environment that depends on Microsoft software, you have my sympathy. But once you see those updates come through, so Patch Tuesday, you should test those things and then launch them. So once it's verified, once you've tested it, ideally in like a virtual server world, you make a snapshot of your server, you apply the patch, you run the patch in a test environment for a little while and make sure it can do all the things, and then you launch it into your production environment. That's a patch management process that will ensure that you've got the right stuff installed and the latest fixes and aren't working with old bugs. And there's all kinds of tools to make sure you're doing it right. One of the things a wise system administrator will do before the boss pays to have a pen testing crew come through is they will scan for vulnerability themselves. They come in a bunch of different varieties. There's scanners that are online. There's some open source ones out there, a bunch of them that are just for Linux, and then a bunch that you pay big money for. There's this thing called the National Vulnerability Database, where the government keeps track of all the various vulnerabilities that they found. And there's a bunch of tools that you can take a look at to do that work, to go through your server and see if there are vulnerabilities out there that are going to blow you up. Nice to keep your server alive. Here is a NStalker security report. Hey, we found this many vulnerabilities. This is Shadow Security Scanner, looking at the resources that it can see on a system. A GFI Events Manager can keep a track of events going on things. But how can you prevent this sort of thing? What are your countermeasures? There's tools to scan your URLs to lock down your IIS for you. But a good Microsoft Systems Administrator will do all these things. Reducing what we call the attack surface of a web server means to minimize the amount of stuff available to users that can potentially be attacked. So if you're running 100 different types of websites that are running applications on one server, that's a huge attack surface. If you can narrow that down and get to just the point where you're basically serving plain HTML, you've like minimized your attack surface. Most real business use cases have to lie somewhere in between there, but such is life. So make the attack surface as small as your business case will allow you to. The Microsoft BSA, or Baseline Security Analyzers, kind of their olive branch to SMBs, to small, medium businesses, to say, okay, so we analyzed your server, and here's Microsoft's recommendations, and here's how you get from where you are to where we think you should be. It basically says, make sure these patches are installed, and this is the recommended server configuration, and this will help you get to the baseline of security that we think you should be at. To mitigate file system traversal, when a user goes from C:\\\www to C:\\/winnt by going to http://server.com and then going // WinNT, because remember, ... would bring you back a directory, and then WinNT would bring you into the server directory. Turn the access controls all that you can on Command exe. Don't let people use that. The only people who should have full control of a server are administrator and system. Later in the life of IIS, they added the web server process runs as IIS user. In Unix, the web server process usually runs as Apache or Nginx or whoever. So only in the context of the web server. Keep an eye on your audit logs. Internet user accounts, ISR, don't give them any permissions, and then do the patch thing. Make sure that you're keeping servers up to date. That will keep you out of trouble. Also, if you take a look at URL scan, you should figure out what a normal HTTP request looks like. If you've got web folders, they should be not on the C drive or whatever the system drive is, but someplace else, so that even if somebody manages to traverse, you're not getting into trouble. Anybody who's not a privileged user shouldn't be able to write and execute in the same directory, particularly not with the web server. If you're stuck using IIS, stand up a firewall in addition to the one you're using. Don't let the administrator be the name of the default administrative account. Get rid of all the default websites that come with it and all the demo code and all that stuff. If there's any unused applications, delete it. Turn off directory browsing so that people can't traverse in. Occasionally there's a business use case for directory browsing. We teach a HTML class where we need students to be able to look at that, so we have to turn it on in certain instances, but it is a pain. Throw up some legal notices. You can hope it helps. Make sure that you've got service patches, hot fixes, templates, security templates. And then always look for malicious input. So if you've got a form that takes user data, if you've got a query that takes user data, don't trust the users, because even if only 1% of them are bad, there's a billion people on the internet. If you can, turn off remote admin. At the very least, turn off remote admin coming in from the web server side or the web side of the server. Go through the old security checklist. Make sure you're auditing everything and logging everything. Minimize your attack surface by turning off any of the services you're not using. Take a look at how your scripts map out. Turn off any protocols you're not using. Play with your ASAPI filters and get rid of them if you're not using them. Make sure you're at a minimum for accounts. Take a look at the IIS metabase. Make sure your file and directory permissions are straight. Make sure your server certificates are legit. We'll talk more about certificates. Turn off any unnecessary shares. Make sure you've got a secure machine config. Limit the use of all ports. And take a look at your code and make sure it is secure. And in a perfect world, run Apache, run Nginx. So, web servers, usually a big deal in a lot of organizations. Every server has its own set of potential security vulnerabilities out there that attackers are going to try and exploit, and that administrators have the advantage of being able to use tools to try and test out their own systems. Ideally, like in a virtual machine world, you make a copy of it, you attack the copy, see what you can break, figure out what you can fix. Talk to you guys later.